Hello, we'll be taking up trigonometric ratios again with some questions which were based on the basic trigonometric 6-square trigonometric ratios. The first and foremost, actually we learn to find the trigonometric ratios, various trigonometric ratios, and apply them as per the question given. Now let me just write down a question and then we discuss. Okay, it says if cot theta is equal to 12/5, we have to prove certain expression that says prove tan square, or this tan square theta minus sine square theta is equal to sec 4 theta and sec square theta. Okay, now it is given that cot theta is 12/b. Cot theta is opposite of tan, so that is base by perpendicular. I'm writing only b by p, so base is 12 and perpendicular is 5. Okay, now let me just draw, as per the information, a small triangle that shows perpendicular to be 5, base to be 12. As because we are talking about a right triangle, I can name this as well BCA. It is right angled at C. Now we need to apply Pythagoras theorem to find AB. So AB square is equal to AC square plus BC square. We need to apply this AB will need to find, because I have to calculate sine theta, which will need a hypotenuse. Even sec theta would need a hypotenuse. I think I made a mistake here because this both seems to be sec. I'll just rectify it. It is sine 4 theta into sec square theta. Now AC was 5 square, that is 25. BC was 12, that's 44. So AB would actually be root over of this, and if I add them, I'm getting 169 root, that's 13. So this is 13. I got all the sides. Now let us calculate and go back to LHS in our question. Which we need is tan square theta. Tan square theta is actually tan theta square. So I'll just write tan square theta minus sine square theta. So tan theta was 5/12 because cot is 12/5. Tan is 1 upon cot theta. So it is 5/12 whole square minus sine theta. Sine theta is perpendicular by hypotenuse. So it is 5 upon 13 whole square, which gives me 25/144 minus 25 upon 169. Okay, if you solve this, suppose I can take a 25 common, I'll be left with 1/144 minus 1/169, and then it is, if I do this calculation, I'm getting this as the LCM will be 144 into 169, and in a numerator it is 169 minus 144. That's giving me 25 upon 144 into 169. So it is 5 square. Again you have a 5 square, and then it is 12 square into 13 square. So 5/12 is Okay, and I need to rearrange. It is perpendicular by hypotenuse. I can write it as, and this is 5 square 6 square, so 5 by 12. This one is perpendicular by base. Am I getting so? No, let it be as it is. I cannot reach the right hand side from this, so I'll take up the right hand side and start somewhere here. God, it's too big. Wait. Yeah, I'll just let the left hand side be this, or I can just make a mark. I need to get RHS as this to prove that okay, the LHS and RHS remain same. Now I try solving the RHS here beside it. RHS was sine 4 theta sec square theta. Sine theta is 5 by 13 whole 4, right? Yeah, perpendicular by hypotenuse. Sec theta is opposite of cos, so it is hypotenuse by base, because it is base by hypotenuse is the cos theta, and this is the opposite reciprocal of it. So I'm getting 5 by 13. Now if I write 5 to the power 4 into 13 to the power 2, here it is 13 to the power 4 and 12 to the power 2. So this gets cancelled out with this. In the numerator it becomes 5 to the power 4 by 13 to the power 2 and 12 to the power 2. Either I make this as 5 to the power 4, that gives me the left hand side is equal to right hand side. We have proved it successfully. Let me now move on to another question. Again I need to write it down. It says the given part here says, given that (16 cot A) is equal to 12. You need to find the value of, I skipped the writing THAE, and I have moved on to the question part. Writing sine A plus cos A by sine A minus cos A. Okay. 16 cot A given. If I can relate anything, you need to think. Either you go directly to find out what is cot A, because cot A will then be 12 by 16, reduce it and find rest of the trigonometric ratios by thereby finding sine, cos, and then replace it here. Also, there is another way of doing. If I can convert this sine, cos, which are all related to cot, because sine by cos is tan, and similarly cos by sine is tan, a cot. And what I can see is if I divide both the numerator and denominator by sine theta, I will be getting a cot theta there. So let's divide both the numerator I'm not writing numerator and denominator by a sine A. Theta here is A. So it would just be sine A plus cos A whole by sine A. Let me use another color to so that you can make out where the denominator starts. Sine A minus cos A by sine A again. Here I get, it makes it sine A by sine A plus cos A by sine A. Here it is sine A, same thing will remain only with the change in the symbol, So that is cos A by sin A. Now in the numerator, if you see, it gets 1 plus cot A by 1 minus cot A. It becomes simple now because I'm directly given a cot A. But once I find the answer, you can do your calculation. If you cannot think it this way, find the sin A cos A from the information given as cot A to replace, substitute them and check if you are also getting the same answer or not. Now I can write cot A from this can actually be taken as 12 upon 16. I'm not reducing it because later on somehow I can do it here as well. Of 3 by 4, I need to clearly write it. It will be 3 upon 4, so I'll write plus 3 upon 4 by 1 minus 3 upon 4. That's, I think, giving me some 7 by 4 by, so it is 1 upon 4. Now if I reciprocate 7 by 4 into 4 upon 1, I'm getting an answer of 7 for this question. I would wish if you can get the answer 7 even by directly finding sine and cos and by substituting it. Happy trying. Thank you.